anyway, lead became a real problem in the atmosphere. So back in the late 70s, they enacted laws saying that gasoline could no longer be made with lead. Now, that didn't happen all at once. They eased it in because cars still were designed to burn leaded gasoline. But in 1980, cars could no longer, cars were engineered to burn non-leaded gasoline. The type of lead that's found in gasoline is called tetraethyl lead. That's the scientific name for the chemical. And when I was a kid, Daddy called premium gasoline ethyl. Once a month, he'd fill his car up with ethyl. He was pretty cheap, because he said that made it run better for the rest of the month. And it did. Lead and gasoline allowed engines to run without knocks and to run smoothly. And the more lead that was in it, the smoother the engines ran. And so people like leaded gasoline. And then when they made it illegal, and they just started designing fuel tanks that only took, or cars that only took unleaded gasoline, they made the holes where the nozzle went in smaller and made the nozzle smaller. And of course, people saying, well, that's dumb. They just reamed out the small hole so that the regular nozzle could go into the cars. And that was before catalytic converters were put in. So they were spitting off even more lead out into the driving cars designed for unleaded gas with leaded gasoline, spit even more lead out into the environment. From 1980 until 2006, the amount of lead in the atmosphere went from 2 micrograms per cubic meter. Now that's hard to even imagine. A gram is about a 1/30th of an ounce. A microgram is a 1,000th of a gram. And so this is given in micrograms per cubic meter. Now if you could imagine a box about a little over 3 feet square in all directions, that's about the size of a cubic meter. So 2 micrograms per, and you say, well, that isn't very much. But it doesn't take much of some of these chemicals. But look what happened after they enacted the law saying you could no longer burn leaded gasoline. There was a transition process over a couple of 3 years where cars were weeded out. They started doing converters where you could use the timing and so forth to allow older cars to burn unleaded gas. And then by 2000, we were down here just very, very small, 1 or 2 or a tenth of a microgram per cubic meter of air. For some reason, after 2004, we've seen a little bit of increase in that. I don't know what's happening there exactly. It might be something that has nothing to do with burning gasoline. But lead being a pretty hazardous material, it gets into your body and doesn't leave, along with mercury. And it can attack your liver, it can impact your memory and brain functions. And so it's a good thing to get rid of lead to the extent that we have. Ammonia is a very common atmospheric pollutant. Ammonia is the byproduct of the decomposition of protein. My first 2 children were born in an era when Pampers really didn't exist. We used cloth diapers and had a diaper pail. You change the kid. If it had some solid stuff in it, you'd go over to the toilet and flush it out. If it was just plain old liquid waste, which is full of a compound called uric acid, which converts to urea, and then urea converts to ammonia. And that's used for fertilizer. That's why manure is a really good fertilizer, because it's got a lot of nitrogen in it. food that we digest, the food that cattle digest, all animals really, is ultimately converted to urea, uric acid, and finally into ammonia. There's the sign. Now, if you're keeping your cattle and so forth inside a barn all winter, which some do, I lived on the premises of a pig farm for a year while a friend of mine was in Vietnam, and I lived in his house out on the pig farm. I got really accustomed to various environments that I hadn't been accustomed to before. If you've ever seen where they dig up even an ancient pig farm, it's very detectable. They open up a new subdivision and dig around, go out to the job site. Yeah, this was a pig farm, you know. So anyway, there's the sign-in sheet. Okay, so ammonia gas enters our atmosphere through the decomposition of animal waste primarily. These big feedlots are putting out a lot of, like we saw in the Food Incorporated movie, are putting out a lot of ammonia. They're also putting out a lot of carbon dioxide. That's another material that's a byproduct of this process, as is methane. All of these gases are released as manure decomposes. Methane, of course, is the most common ingredient in natural gas. It's the most common volatile or burning type gas that's naturally produced in the atmosphere. Now, too much ammonia can be bad for you. When I was, up until just the last couple of years, we kept household ammonium hydroxide, which is the liquid form. When you bubble ammonia through water, you get ammonium hydroxide, and that's used as a cleaning product. And I used ammonia to wash glass and all kinds of stuff. But they're finding out now that ammonia gas, if you breathe too much of it, it's caustic to the lining of your lungs and not good for you in general. So now we use lemon juice until they find out what's wrong with it. Okay, so ammonia. So we've had carbon monoxide, monoxide, lead, and ammonia are major outdoor air pollutants. Something you don't think much of are particulate pollutants, those that are particles. That's a microscopic view of what's been filtered out of some air. Every time you take a breath, you're inhaling a lot of particles. During pollination seasons, you're inhaling a lot of particles, and those are naturally produced, so we can't blame them on human activity. But volcanoes produce ash. In other words, ash and dust are considered particulates. Soot from open fires is considered a particulate, or from the burning of coal. But they occur naturally. Dust storms, forest and grassland fires, the pollen from living vegetations, and then of course, by our burning of fossil fuels has something to do with it. It's produced in power plants, it's produced in industrial processes. So we're filling the air full of a lot of particles. And it seems like the air is dirtier than it used to be. And it is in large degree. But if you would draw some air through a filter and then magnify it, it would look something like that. All kinds of particles. And some people are very sensitive to particles when they inhale them. It creates a lot of bronchitis or asthma type symptoms. Can you imagine